In this video, we're going to get started on Chapter 14, Solving Multi-Step Equations. Okay, in Chapter 13, we saw some pretty difficult equations. Most of them required two steps to complete. Another difference that you're going to see between the equations in Chapter 14 and 13 are that we're going to be solving equations with a variable in several places, or in some cases on both sides of the equation, the equal sign. Okay, so the goal of chapter 14 is to use these guidelines, and we have 4 of them, to get back to the type of equation that we had in chapter 13. And so once we get to that point, you should be pretty familiar with chapter 13 and undoing the steps to get the variable by itself. Okay, it takes a little bit of practice, but basically chapter 13 was about learning the order of operations backwards. Okay, so by now you should know the order of operations forward and backwards. So what are these 4 guidelines? Well, the first one is use the distributive property to remove all grouping parentheses. That could be brackets and not just parentheses. Any grouping symbols. 2. Multiply both sides of the equation by the lowest common denominator to remove all fractions. This is one thing that we worked on in chapter 13, so this is nothing new. 3. Combine like terms, and we already have a little experience with that. 4. Solve the equation using basic solving techniques. So by the time we reach step 4, or guideline 4, we should arrive at something that looks similar to the equations that we solved in chapter 13. So let's get started. Our first equation that we're shown is 2x minus 8. We have in parentheses multiplying the 8 of 4x plus 9. So there's a 4x here in the parentheses and a 2x on the outside, equals 42. Alright, so we're going to sort of follow a tutorial. Okay, the answer is going to walk us through the steps to solve this equation. Alright, guideline 1 is what we're doing in this step. Perform the distribution. If I distribute the negative 8 to each term in parentheses, that includes 2 terms. So I would say negative 8 times 4. That would give me a negative 32x. And a negative 8 times a 9 would give me a negative 72. And distribute the negative along with the 8. So first step, get rid of the parentheses. There's no fractions, so we can skip this second step, which leads us to, and we've completed the first one. This leaves step 3, combine like terms. And up above, you should see that we have 2 like terms, 2x and then the minus 32x. So we're going to combine these into 1. And I'll write that in red. Negative 32 plus 2 would be a negative 30x. Then we just bring down the negative 72. And at this point we are back to an equation that resembles those from chapter 13. To solve this, we would add 32 or 72 to both sides and then divide by negative 30. Now all of the math that we've done so far only concerned the left side. Alright, we added things that were on the same side. So there was no need to transfer any numbers over to this negative 42. As you should notice, we have the same number on the right as we started out with. Negative 42, negative 42, and in the end negative 42. All of the operations were carried out on the left side. We were really just sort of reorganizing things to get it to an equation where it's more obvious as to what we need to do in order to get the x by itself. So in the space below, we will take our equation, carry out the steps. The x is only in one place, it's on the left side, and we begin by adding 72 to both sides. Negative 42 plus 72 would give us a positive 30. And the negative 30 is multiplying the x, so we do the opposite and we divide by negative 30 on both sides. And in the end we are left with x, and 30 divided by 30 is 1. We had one negative, so our answer in the end is a negative 1. If you don't mind a little extra work, you can go back, plug the negative 1 into the left side to check your solution. This is the left hand side, and we want this to work out to be negative 42. So here we have the grouping symbols with the negative 8 on the outside. We don't have to distribute the negative 8. We have all the numbers that we need on the inside of the parentheses to calculate that first. Alright. This product is separated from this product by subtraction, so I can go ahead and multiply this 2 times the negative 1 and get a negative 2. 4 times the negative 1 on the inside is a negative 4, and then we pick up the plus 9 to the side. Still working inside the parentheses, negative 4 plus 9 is 5. And now negative 8 times 5 is minus 40. And so in the end, we have negative 40 and a negative 2, which works out to be a negative 42. And that just simply equals the right hand side. So x equals negative 1 checks out as our solution. Here we have an equation with no parentheses, so we skip step 1 and we go to step 2, which says that we want to get rid of all of the fractions. And notice that the 1 doesn't have a denominator written, but we would still multiply this 1 by whatever number we come up with for the lowest common denominator. So what is the smallest number that 2, 5, and 2 will divide into? That would be 10. And as in the previous chapter, we multiply both sides of the equation by 10. Alright, and so you see 1/2 y minus 1 inside the parentheses. This is just the left hand side of the original equation. And then we have 7 over 5y plus 3/2. So here is the right side in parentheses. Here is the left side in parentheses. And both of them are being multiplied by 10. This 10 is going to wipe out all of the denominators. So, as with any set of parentheses and a number outside, we are going to distribute. I'll draw my distributive arrows. For every term that has a denominator, I will simply take that denominator, divide the 10, and then whatever I get from that, I'll multiply what's left. So 2 or 10 divided by 2 gives me 5. 5 times 1 would give me 5, and then a y. The 1 here doesn't have a denominator, and so we would just multiply 10 times the 1 to get a minus 10. That completes the left side. Now for the right side, 7 over 5y has a denominator of 5. So if we divide the 10 by the 5, we would get 2. And so we would multiply the 7 by 2 and get 14. This number was attached to a variable, and so this would be 14y. Now for the last part, term inside this parentheses, we now have a 2, which is in the denominator, and so we would divide 10 by 2. We would get a 5, and that 5 we would multiply by 3. So you can see down here in the next few steps, the next bit of explanation, we have 5y minus 10, 14y, and then 5 times 3 is 15. Here is a new situation that we haven't seen before. We have a y on the left and a y variable on the right. Okay, if you want to move something from one side to the other, which is kind of what we're doing with the 5y, we have to do the opposite operation. So if you look in front of the y on the left side, you would interpret it as a plus 5y. So in order to combine it with the 14y on the opposite side, we would change the sign. And you only change the sign of this if you're combining it with something on the opposite side of the equal sign. Otherwise, we would keep the same sign and combine like terms the way we usually would. So here we have to say subtract 5, subtract 5. 5 y's cancel out on the left. We bring down the negative 10. 14 minus 5 is 9y, and then we bring down the 15. This second last bit on page 99 is just showing you an alternative route you could have went. Instead of moving the 5y over to the right, you could have moved the 14y over to the left by subtracting it from both sides. And as a result, you'd end up with a slightly different equation. So you don't want to do both of these. You either want to move the 5y to the right, or you can move the 14y to the left. So either one of these is okay, this one or that one. Either one of these equations will result in the same y. Use one or the other, not both. Either one is going to give you the same answer. So the workbook is going with the original one, the first one. And at this point, this equation matches up with the equations that we solved in chapter 13, two-step equations. We focus on the side with the variable. 9 times y plus 15. We do the order of operations in reverse, undoing each operation. So plus 15 is undone by a minus 15 on both sides. And in a sense, we're sort of moving numbers away from the y variable. Negative 10 and negative 15 gives you a negative 25. The 15's cancel on the right. Y is multiplied by 9. So if we get rid of the 9, y will be by itself, and we'll be done. Opposite of multiplication is division. The 9's cancel on the right. So we finally have our y variable by itself, and our answer is negative 25 over 9, which can't be simplified. Moving on to example 1. We have a similar situation as we did in the previous problem. Notice that there is a v term on the left and a v term on the right. So one or the other one is going to have to move to the opposite side. I usually move the term with the smaller number, which in this case would be the minus 10v. So in order to combine this v with the minus 3v, I have to do the opposite operation. I have to add 10v to both sides. The 10v's cancel on the right, leaving only a 30. A negative 3 plus 10 is 7v. I bring down the plus 2. And here we have a two-step equation. Focus on the side with the variable. There's a 7 and a 2. We want to get rid of those two numbers so that v's by itself. We must get rid of the 2 first by subtracting it from both sides. $30 minus 2 is 28. Now the v is being multiplied by 7 only. We undo that by dividing by 7. That yields v equals 4. 7's cancel on the left, leaving only a v on the left side of the equation. 28 divided by 7 is 4. Example 2. Now the variable is on the same side, however we have some parentheses that we need to deal with by applying the distributive property. So we're going to leave most everything alone. 2w. The right side is going to remain negative 36. And we're just going to mess with the parentheses. We're going to distribute the 6. 6 times w is 6 with the w beside it. And 6 times a negative 8 is a negative 48. Once you multiply everything inside the parentheses by the number on the outside, in this case the 6, we no longer need the parentheses anymore. So I would recommend not writing those on this next line at all. Alright. In contrast to the previous example, these variables are now on the same side, and so we simply go with the signs that were given in front. This is a -2 and that is a +6. These like terms are on the same side, so we simply use the signs we're given, -2 +6, and then we put a W behind it. Just to combine like terms. We are combining these into one term. We'll bring down the -48, bring down the -36, and this just turns out to be a 4W minus 48 equals a -36. So we're back to a two-step equation. We add 48 to both sides. 48's cancel on the left. We bring down our 4W. 48 minus 36 would be a 12. And so we reevaluate what we need to do to our equation. We now have a 4W equals 12. 4 is multiplying the W. I want to do the opposite and divide by 4. I divide by 4 on both sides. The 4 cancels on the left, leaving a W on the left by itself. 12 divided by 4 is 3. Example 3. We now have a set of parentheses, and the variable is in different places on opposite sides of the equation. So our guidelines are 1, get rid of parentheses. 2, get rid of fractions. So this is a little abbreviated, but these are the things that we want to get rid of. 3, combine like terms. And then 4, at this point, we should be at a two-step equation. Solve the two-step. Alright, so parentheses are the first thing that we want to address, and they are only on the right side, so I'm simply just going to rewrite the left side. There's nothing to do there yet. On the right, I want to distribute the -7. That will give us a -7y, and then -7 times a -3 results in a positive 21. There are no fractions, so we don't have to address the second step, or the second guideline. That brings us to number 3, combine like terms, and the like terms are on opposite sides. So we're going to have to change the sign of one of them. -7 is less than 2. I usually just move the smaller one. So if I move the 7y, then I have to say plus 7y, because it's -7 on the right side. So if I add 7y on both sides, the y term cancels on the right, leaving only a 21, and then the terms are combined. So 2 plus 7 is 9. Bring down to -6. And now we are at step 4, solve the two-step equation. There's only two numbers associated with y on the left, a 9 and a negative 6. So therefore we have two steps. First step would be to add 6. That leaves a 9y on the left. 21 plus 6 is 27 for the right side. Ultimately, I want the y by itself. It's being multiplied by a 9. So I do the opposite and I divide both sides of the equation by 9. 27 divided by 9 is y equals 3. Example 4, a lot of things going on. We have 3 variables, u, 2 on the same side, 1 on the opposite, and we have 2 sets of parentheses. So according to our guidelines, we take care of the parentheses first. So on the left, we could distribute the negative 4. On the right, distribute the 5. So we can do a lot in one step. What I do on the left side, as long as I'm not trying to move a term to the right, doesn't affect the right side. So distribution here, distribution there, it's okay to do in the same step. Negative 4 times 4 is a negative 16. U. Negative 4 times a negative 2 is a plus 8. That takes care of these parentheses. I can bring down my 7u. Now to distribute on the right, we have 5 times u, and then 5 times 4 would give us 20, and we no longer need the parentheses. On the left, I have two like terms that I can combine. So we'll do what we can on the left and the right separately. So I'm still working on the left. I don't want to start moving anything back and forth across the equation yet. On the left, I have the negative 16u and the 7. So I simply combine the numbers and put the u behind that and bring down the 8. You could combine negative 16 and 7 in your head and skip these parentheses here, but I'm just merely showing that we are adding negative 16 and 7 to combine like terms. That gives us a negative 9u plus 8 equals 5u plus 20. So now the only like terms, there are no like terms on the right. There's only two. This one has a u. That one does not have a variable, so these are not combinable. And same situation on the left. We can't combine these two on the left, so now we have to jump across the equal sign. I want to get my u's combined into one term. If I move the 9u to the 5u on the right, then I have to add the 9u. So the 9u's cancel on the left. I'm left with an 8 equals 9 plus 5 is a 14. So now on the right we have 14u plus 20. We have arrived at a two-step equation, so to solve this, I simply want to get the u by itself, which means I have to get rid of the 14 and the 20. you have to start with the 21st and subtract it from both sides. 8 and negative 20 is a negative 12. The 20's canceled on the right, leaving only a 14u. Refocus on the variable, and there's only one number paired with it, the 14. The 14 is multiplying the u, so to get rid of it, you divide. So in the end, we have negative 12 over 14. This can be reduced because both are divisible by 2. 12 divided by 2 is a 6, and 14 divided by 2 is a 7. And the 14's canceled on the right, leaving only a u. And so our solution is this, negative 6 over 7. Equation B. Another equation with two sets of parentheses. Here on the left we distribute the negative 5. On the right we have a 7, and we distribute that through these parentheses on the right. So that's our first step. Negative 5 times a negative 2 is a 10. Just multiply negative 2 times negative 5 to get the 10x. Now we distribute negative 5 to a plus 6, and that results in a negative 30. Don't forget the negative 7x. It wasn't involved with the parentheses, so we just bring it down alongside the 30. Addressing the parentheses on the right, we distribute the 7. Gives us a 7x, and then 7 times a negative 3 is negative 21. We subtract 7 on the right. And now we'll just focus on the left and right side separately. So, because there's some terms on those sides that we can combine before we start trying to jump across the equal sign. So, on the left side, we have a 10x and a negative 7x that are like terms. And then on the right side, we have a negative 21 and a negative 7 that can combine. We are not moving these across the equal sign. We're just combining them with something that's already on the same side. So we use the signs that they have already. 10 minus 7 is a 3x. And then we just bring down the negative 30 to the side of it. On the right, there were no other x terms, so we just bring down the 7x. And then 21 and 7 are on the same side, so we use their signs. They're both negative, so that would give us a negative 28. And now we need to combine the x terms, and they're on opposite sides. So one of them we will have to change the sign to get it to the other side. I will move the 3x and combine it with the 7 on the right, so I'll have to subtract 3x. The 3x is canceled. 7 minus 3 is a 4x. And here we are at a two-step equation. To solve this, we add 28 to both sides and then divide by 4. Twenty-eights cancel on the right. Negative 30 plus a 28 results in a negative 2 on the left side and a 4x on the right. X is being multiplied by 4, so I divide both sides by 4. The 4's cancel, leaving only an x on the right, and a negative 2 divided by 4 is a negative 1/2. Example 5, we have an equation with fractions now. So we worked a bunch of difficult equations on the previous page, parentheses, variables in several places. So now we'll sort of switch gears and work some with fractions. Once again, we do not fool around with the fractions throughout the entire problem. Our first step is to get rid of the fractions. And so we use the lowest common denominator in a different way. We take the two sides of the equation left side, right side, and we are going to multiply by the lowest common denominator, whatever that may be, on both sides. And that will wipe out the denominators. And at the same time, numbers without denominators will just simply be multiplied as you usually would with the distributive property. So what is the lowest common denominator of 3 and 2? Then we have another 3. Well, smallest number divisible by 3 and 2 is 6. So go back and write a 6 multiplying both sides. So we distribute this 6. Now, if a term has a denominator, then what we'll do is we'll say, take that denominator and divide it into the 6. So with this first one we have 3 divided into 6 gives me a 2, and that will multiply the negative 2x on the top. Our next term in the parentheses, 3 over 2, we divide 2, the denominator, into the 6. That gives us a 3 that we now multiply by the 3 that was already on the top. Just a coincidence that we ended up with 2 3's, 3 times 3. Alright, now for the right side, 6 times a negative 7 gives us a negative 42. There was no denominator. You could say that this is a 1, but 6 divided by 1 is 6, and so we still end up multiplying the 7 on top by 6. The 7 had an x attached to it, so the negative 42 has an x as well. And now the denominator for the 2/3, 3, divides into the 6 and gives me a 2, which I multiply by the 2 on the top. And again, that's just a coincidence that we ended up with 2 2's. The 1 2 came from the top, and the other one came from 6 divided by 3. So we'll go back through it and clean it up. Not really moving things around. We need to carry out the multiplication. 2 times negative 2 is negative 4x. 3 times 3 is a 9. Negative 2 times 2 is a negative 4. And now we have an equation. We're pretty close to two-step equation, but the x's are on opposite sides. to combine them, I have to change the sign of one of them. I'll move the 42, so I'll write plus 42 since it started out negative. So plus 42 on both sides. On the left, that is going to give me a 38x plus 9. On the right, the 42's canceled, and so I only have a negative 4 on the right, and the 38 is positive. So we have made our way to the two-step version of this equation. We simply have to get rid of the 38 and the 9. The first step is to subtract 9 from both sides. Negative 4 and negative 9 would be a negative 13. The x is now being multiplied by 38 only, and to undo that we divide by 38 on both sides. The 38's cancel, and we are left with x equals negative 13 over 38. Moving right along to example 6. Linear equation, several occurrences, fractional forms with binomial numerators. The binomial numerator simply means that, for instance, this fraction, large fraction bar, has two terms on the top, something plus something. And so does this one over here on the left, t minus 9, and both of those are being divided by 6. We treat this as we did the previous problem. We have fractions, and so the first thing we want to do is get rid of them. So we just look at the denominators. We have a 6 and a 5. Smallest number divisible by 6 and 5 would be 30. It looks like a 36. Should be a 30. Multiply both sides by 30. And notice on the left I only drew one arrow. That's because we treat this entire fraction as one term. So we would take the denominator as we have before and divide it into the 30. I'll write this one out. You can look at it as writing 30 divided by 6 times t minus 9. And then this one, well, this one's a little bit trickier, okay, because we have to distribute the 30 twice. And so what I need to do is write a 30 beside this 4. So 30 times 4, and then for the 8t plus 1, I can write 30 over 5 beside it. The 4 didn't have a denominator, so we just simply write 4 times 30. So now 30 divided by 6 is 5. 4 times 30 is 120. Divided by 5 is 6. And also notice this subtraction sign was written level with the fraction bar. That means that this is a subtraction symbol. This subtraction needs to be distributed to the 8t and the 1. Okay, so I wrote it this way, outside a set of parentheses around the 8t plus 1. So now we have some parentheses in our equation, and we need to take care of those by distributing. 5 times t is 5t. 5 times a negative 9 is negative 45. Now, this is going to look weird because I have a set of parentheses and there's actually two numbers multiplying it. One behind it, the 6, and the other one a negative 1 in front. So if you wanted to, you could do both of these at the same time, but I'll just distribute the 6, and so I have to keep the parentheses. 6 times 8 is 48. 6 times 1 is plus 6. Okay, keep in mind that all this negative, the parentheses, and the 6 are all being multiplied together. If we had wanted to, we could have rewritten this as a negative 6 times an 8t plus 1. Multiplication is commutative, so we can rewrite things this way. All right, but I did it differently, sort of going the long way. And so now I need to distribute the negative. So I have a minus 48 and a minus 6. On the left, there's nothing to do. On the right side, though, we do have some like terms. The numbers, the 120 and the negative 6, those two can combine on the right without changing the signs because they're on the same side. So I'll move my equation up here. 5t minus 45 equals, alright, 120 minus 6 would be 114, and then I bring along the minus 48t. So now, looking at our equation, we have no like terms only on the left, and then if we just look at the right side, no like terms there either. So what we need to do now is combine the t terms that are on opposite sides of the equation. I will move the 48t. To do that, I want to move it to combine it with the 5t on the left. I have to add it. So 48 started with a negative. I add 48t to move it to the left side. On the right, the 48t would cancel, leaving only a 114. 48 plus 5 is 53. Bring down the minus 45 along with it. This is subtract 45. So here we are at a two-step equation. To solve it, we add 45 to both sides. 45 plus 114, 159. And now to solve for t, it's only being multiplied by 53, so we divide by 53 on both sides. And we simply look at the variable to figure out what needs to be done. We want to chip away all the numbers that surround the variable. So finally, we have the t by itself. 159 divided by 53 is 3. T equals 3. And once again, you can check that. Just plug it back into the original equation. This is just the left hand side. That would give us a negative 6 divided by 6, which is negative 1. And then for the right hand side, I'll move that up here. We would have 8 times 3 plus 1 on the top divided by 5. 8 times 3 is a 24 plus 1. So now we have 4. Subtract 24 plus 1 is a 25 on the top. 25 divided by 5 is 5. And 4 subtract negative 5 is negative 1. And here we have the two sides match. Left hand side equals right hand side. So our solution checks out. Alright, page 103. So far, all of the equations that we've solved have yielded a number for the variable in the end. X equals some number, x equals 4, x equals negative 1, x equals 3. Well, it turns out that there are two types of equations where we actually do not get a numerical answer in the same sense that we have been so far. Alright, there are two types of equations. One is called an identity. The other one is called a contradiction. So first we'll look at an identity, and this equation here is one such type of equation. Something just equals the identical expression. X plus 5 equals x plus 5. Same expression on each side. Well, if we were to go about this in the usual way, that's not exactly what they want us to do first. They want us to pick a number for x. It can be any number. Let's say negative 3. Well, if we insert that into our equation, we have x on both sides, these two blanks. Negative 3 plus 5 is 2. And then same calculation on the right with the same number. So, of course, we get 2, and both sides are equal. Is that statement true? That would be yes. If we had used a different number for x, would it still be a true statement? Of course. Why? Because we're doing the same operations on both sides to the same number. So if we were to pick a different number, as long as we put the same number in the blanks on each side, then we just simply add a 5 to it. So let's say I picked 4. This works for any number. 4. Well, on each side I add 5 to 4, so on each side I get 9. The two sides equal. This is referred to as an identity equation. Alright, here's the usual way that we'd go about it. If we had no idea what an identity equation was, then more than likely if we solve this equation we would say, well, the x's on opposite sides and they're like terms and I want to combine them. So to move one to the other side, I change the sign. I say minus x, and on both sides you see that x minus x just gives you 0. The x's cancel and we end up with 5 equals 5. This is what happens with an identity equation. You may not necessarily come up with the number 5 on both sides, but it will be a number equal to itself with no variables involved. Now, For the other type of equation, it's called a contradiction. One such type of equation is listed here. On one side, we add 5 to a number. On the other side, we add 4 to that same number. We will never get the two sides or the two numbers to be equal. Alright, so let's try a number anyway. Let's say -5. So on one side I take -5 and add 5, I get 0. But now on the right side I add 4, I get a -1. So it's obvious that the two operations that happen to the number that I pick will never match up the left and the right hand side. No, this is not true. Is this statement true? No. If we had used a different number for x, would it be a true statement? No. It never will, no matter what number you pick. This is called a contradiction. You recognize it simply by going about solving the equation in the usual way, and in the end the variables cancel out completely and you have a number equal to a different number, which is never true. In this situation, we say that there is no solution. Alright, so once again, if we had x plus 5 equal x plus 4, we'd want to combine the x's, which are on opposite sides, so one of them we would have to subtract from both sides. That would cancel the x's out on each side. There would be no variables left in the equation, and we'd have 5 equal 4. Two numbers that aren't equal. The most important thing to know about this situation is that there is no solution to the original equation. There is no number that we can plug in for x to where the two sides will equal. Alright, example 7. Solve and decide if the solution is no solution, one solution, or all real numbers. We don't do anything differently than we have before. We are just now aware of two other types of equations, or two other ways to interpret a certain type of result. So we go about this the same way we have been, expecting to get a number for our variable. Parentheses mean that we distribute to get rid of them. There's parentheses on each side. So on the left, 3 times x would give me a 3x. 3 times 2 would give me a plus 6. And I'd bring down the minus x. 2 times x would give me a 2x on the right. Then I distribute the 2 to the -1. And then I just simply bring down the 5 alongside the 2. On the left, we have, just focusing on the left, we have two x terms, 3x and a minus x. To combine them, we would calculate 3 minus 1, which is 2, and we'd attach an x to it. Then we'd bring down the 6 alongside it. So these two terms were combined to give us one term, 2x. On the right side, a -2 plus a 5 gives me 3. And now you see that we have a 2x on each side, but with a different number being added to it. So at this point you may recognize that this is going to turn out to be a contradiction. If we continue and we say, well, we want to combine like terms, the terms are on opposite sides, so I change the sign, plus 2x means that I subtract 2x to combine it with the one on the left, but the variables cancel out on each side. 2x's cancel on the left, 2x's cancel on the right, and I end up with a number equal a different number. 6 equal 3. Doesn't matter what the numbers are, they're just not equal. So we say this is a contradiction. Is a contradiction. So there is no solution. There is no x. There is no number that we can plug in for x that will satisfy this equation. No solution. B, once again, we just start out trying to solve for x, figure out what the number is. We have parentheses, so we distribute. 8 times x is 8x. 8 times a negative 1 is negative 8. We bring down the negative 4. On the right, we distribute and we get 8x. 4 times 2x is 8x. 4 times negative 3 is a negative 12. On the left, we have two numbers, like terms, a negative 8 and a negative 4. They will combine to give us a negative 12. And at this point, you see that the two sides are identical expressions. You can keep going. If you try to combine the x variables, subtracting 8x from each side, the x variables cancel out and we are left with a number equals itself. This is an identity. So there are an infinite number of solutions. Basically, any number that exists, you could plug in for x, and it would work. X is all real numbers. Any number. Example 8, identifying properties used to solve a linear equation. The equation 5 times 3x plus 4 equals negative 10 is solved in several steps below. So we have to recall the properties from, let me see, I think it was chapter 11. We had commutative and associative property of addition and multiplication. We had the identity property of addition and multiplication, the inverse property of addition and multiplication, and we had the multiplication property of 0, and then the distributive property. So from this equation to that one is our first step. So what property did we apply there? Well, we simply distributed the 5. 5 times 3 is 15, 5 times 4 is 20. So we label that step as the distributive property. Then we went from this equation to that one in step 2. Here we are applying the additive inverse property. We have a 20 and we are adding a negative 20 to both sides, or we are subtracting a 20. Same thing. So we will write additive inverse. Okay, from this equation to that one is our third step. What property was applied? Well, um, the 20's canceled. Negative 20 plus a 20 is 0. Okay, and so this was a 15x plus 0, and we wrote it as a 15x. So we would call this the additive identity. Property. Step 4, we could look at, here we have a 15 beside the x. Dividing it by 15 is the equivalent of writing 1 over 15 times 15, which is probably more easily recognized as the multiplication property, or the multiplicative inverse property. So 4 is multiplicative inverse. Okay, and now 5, you need to see that we took 15 multiplied times its inverse, and so there's sort of a step you could write in between here, but we normally don't write it out. 15 over 15 times x is equal to a 1 times x, which we have just written as an x. And so this is the multiplicative, it's hard to say, identity property. A number times 1 is just that number, or in this case, x times 1 is just x. And so we've rewritten the left side as an x instead of a 1x.